Hello! I'm going to talk about the advanced programming features of Sass and how they're useful and how you can sort of structure Sass libraries and challenges you may run into doing that and so on. Because with every release of Sass, it becomes more usable as a programming language. So why would you want to program in Sass? You can have reusable parameterized components that you can share between different pieces of code, as you probably know. And this lets you save time, it keeps your code maintainable. The computer does boring repetitive things, so you don't have to. And you can also do some things that just wouldn't be feasible in raw CSS. So let's look at an example of where the programming features of Sass can make our code better. And this is an example based on something I read online that said if you keep the saturation and luminosity the same when you're choosing colors for a design, the colors should work well together. And that seems a bit simplistic to me. I don't know if it's true. There's a color theory talk later today, so maybe we'll find out. I don't know. But I think it's still a good example. So you see we have some repetitive code here. And we can eliminate the repetition with a for loop. And we can do even better than this and put it into a mix-in. And the weird formatting of the arguments there is because my picture is going to go there when this talk is recorded, so I had to break it up. This is easier to understand. And it's also easier to use in future when you want to use different colors or different steps between the colors and so on. And you can reuse it across projects. So that was a fairly simple example just to sort of introduce why the programming features of Sass are at all useful. And now I want to go on to something that's more complex. And in this example, I'll be talking less about the actual here's a for loop, here's a mix-in, and so on, because there's lots of information about that. And what I want to focus on instead is the challenges you'll face working with Sass to do something that's reusable and can be packaged as a library and so on. So when I say API library here, I don't mean it's for doing HTTP requests from Sass directly or anything. I mean it's for hooking into services that will embed third-party CSS into your own. And the most prominent example of this, and actually the only example of this that I know of, though there must be others, is Google Web Fonts, which has an API for getting font face rules that you can drop into your CSS. And it's heavily customizable. You can specify the fonts, the variants, which are like the numeric weight of the fonts you want, whether you should have the italic versions. You can do subsets like Latin and Cyrillic and so on. But before we use Sass to make this easier, what you have to do when you want to use this is go to the Google Fonts website, and the interface is pretty clunky, and you have to redo this every time you change the fonts that you want. And over the course of your project, as it develops, you're probably going to want to change the fonts a few times. Because you might want to start with having all of the weights of a font so you can play around with them and work out which ones you want to use. But then, when you're actually ready to go into production with your website, you don't want to download all 10 font weights that you're not going to use. So you'll have to go back to Google Web Fonts and get the new font face URL and drop it back in and go through the whole process again. So the first thing we need to think about when we're going to abstract this and make it easier, and I should say this is a project that I have done, this is a real experience that I am drawing from. The first thing that we want to do is design an API for people calling this code so that it's usable. And we need to allow people to customize all of those parameters that we saw before. But we also want it to be nice and short if someone just wants to use the default parameters They don't have to specify them or leave a load of blank bits. And something that you might not have thought about until it bit you, like it bit me, was that your API needs to be compatible with Ruby Sass and libsass. Because while they're theoretically the same language, libsass tends to lag a bit behind. And there are some weird edge cases that libsass has that you have to hack around. And the fun thing about these edge cases is that generally when you find them, you are the only person that has ever encountered them. So an example of one that I came across was when I was trying to do the import rule to import this extra style sheet from Google Web Fonts. First, I had that included in my mixin, and it would just output the import when you called the mixin. But that didn't work with libsass. So I had to change my API and do a new major version. And so I thought, OK, we'll go with the import statement and make the user call that themselves. And we'll just have a function that generates the URL, and they can pass that into the import rule. But that also doesn't work with libsass, because the import URL statement cannot take arbitrary values. It can only take strings and variables. So I now have a section in my README that says, if you're using libsass, the syntax I've used here won't work. You have to make a URL. You have to make a variable and put the URL in it first, calling the function, and then import from the variable. And this took a very long time to figure out. The GitHub issue for this problem that didn't work with libsass was open for a year, with various people chiming in before we eventually found something that worked. So taking all of those API considerations into account, we were able to come up with one that worked pretty well. If you just want to import a font as standard and just get the default parameters, you can do that, and it's nice and short. But there's also syntax for specifying all of those parameters if you want to do a more advanced use case. Another challenge that I came across in this that I think is probably something that's likely to hit a lot of people trying to do a similar thing in creating some Sass library that does a lot of programming behind the scenes, was URL encoding. And to do this, we needed to have string replacement. And string replacement is something that you would expect a programming language to have. It's a pretty common thing you have to do. But Sass doesn't have it. And so you have to implement that yourself. And you can do this with finding the index of a string within another string and slicing up a string functions. And it's a pain to do, but it is now possible in Sass. It didn't used to be possible in Sass, and strings used to be completely opaque. And so there were no functions available in Sass that you could use to do any sort of string manipulation, which made this sort of thing impossible. I sort of did it anyway, and since it's not relevant information anymore, if you're curious, you can ask me how I did it after. And another problem that you run into when you're trying to design a library in Sass is that there's no module system. So when you are telling people how to import your code, that's going to change depending on how they've installed it. So you can't just give people code they can copy and paste and say, after you've installed it, do this. And additionally, all of the functions you write in your Sass library are public. So I have my string replacement function. It's very likely that another library is also going to want to do string replacement. And so we'll have its own string replacement function. And if they're called the same thing, then everything will just break. So to get around this, I prefixed all of my functions that were not intended to be called by other people. But that's still not a great solution because someone could use the same prefix. And this is going to be fixed, both of these problems, with modules in Sass 4. You can see the proposal that they have for this and read through it. It's very thorough, and it's on GitHub with the link there. And it provides syntax for actually having Sass modules with private functions and mix-ins and variables and so on. And this is going to make, depending on third-party code in Sass, a lot safer. Another thing that you might want to do when you're developing a Sass library is have tests for it. And for example, when I had to change the API in that library, I wanted to make sure that the actual stuff that was outputted when it was finally compiled to CSS didn't change. And there are various approaches to unit testing in Sass, because it's a problem that I think people it comes across rarely enough that you're doing something complex enough to warrant it. And everybody who does it comes up with their own solution. So we're going to look at 3 of them. The first one is called Bootcamp, and it is no longer maintained, but it provides a BDD-style full test suite implementation, and it's all written in Sass. I think this is amazing that this is possible. But it's sadly been abandoned, and I also think it's probably more complex than you need for most circumstances. So an approach that I like better is one that I saw from the SassMQ project, which provides like mix-ins for doing breakpoints and stuff. And what they did, I thought, was really clever. And it was just they had a test directory with CSS and SCSS file pairs, and they would just compile the SCSS files, which would overwrite the corresponding CSS files. And then they said, just run git diff, and you'll see if anything has changed, and if it has, you can go back and fix it. And I thought that was really cool, because you don't have to do anything yourself. There's no real complexity to it. But it's a bit of a manual process, having to compile the files and go and do the git diff and stuff. So my solution that I use for my libraries is called SassUnit, and it's basically the git diff approach I just described. But I used a Ruby testing library and just loop through the file pairs in whatever directory they're in, and generate a test for each pair saying, compile this file and check if the output is equal to this one. And it works very well. Because it's built on an existing testing library, you get all sorts of features that you wouldn't otherwise get from a testing library that was maybe built just for Sass, because there probably isn't going to be as much investment in it. And because it's automatic and it runs all the tests at once and so on, you can test with multiple implementations of Sass at once, or you will be able to soon when I add that, but it should be there soon. So that's my more detailed example. And in designing this, we were able to make a simple API that people could use and not have to go through the clunky Google Font interface. And it makes it easier to change your code in future, because if you're changing the font, you just have to do it in one place, which is in your code. And this has become relatively popular. It has a few hundred stars on GitHub. That's pretty cool. And so I hope that the lessons that I've learned from doing that are things that are transferable to other libraries you'll want to write with Sass that are more complex programmy ones than outputting lots of CSS ones. And I have a few more bits of advice that I want to give for when you're developing this sort of thing. The first one is to use all of the statements that Sass provides. These are not things I see used often, and they're really helpful when you're developing. Debug, in particular, lets you inspect the values of variables and stuff, which can be really important, and there's not a clear way of doing that in Sass if you don't know about debug. And there's also error, which is a bit like an exception. It will just stop executing immediately. There's sadly no way to catch the errors. You could do some really cool stuff if we could do that, I think. But it does not seem to be possible. And there's warn, which is pretty much the same as debug. But it'll say warn in front of it instead of debug. And another thing you should be aware of that's really helpful in actually any kind of Sass development is the Sass Script interactive shell, which you can get by running sass-i on the terminal. And it lets you test out Sass Script expressions in a console. Sass Script, by the way, is a subset of the Sass language. And it's basically, if you think of, you're going to have like background 1 pixel plus 2 pixels or something, it's the stuff that goes to the right of the colon, so the value stuff. And it's useful for testing units in particular, because Sass units can do some weird stuff if you're doing math on them. And it's also useful for testing the Sass library functions that it comes with, like the color ones or the string ones. If you just want to get an idea of what they do, this is the best way to do it. And it also does variables. You can assign to variables with a colon and reference them later. It lets you call functions, but as far as I know, there's no way to define your own functions in this way. So that's a limitation that you should be aware of. And that's mostly what I have to say about complex programming tasks with Sass and the challenges you'll face in doing them. But I want to talk, before I close, about one more method, and that is not programming in Sass, and instead extending it. I'm not going to go into detail here, because it's not really the subject of my talk, but I think it's something to be aware of. The Sass implementations both provide you with a way to hook into the compiler and do your own things, expose your own functions and so on. And you write them in the language of the compiler. And this means that your code will only be compatible with that specific Sass implementation, which is why I think it's better to actually program in Sass when you can. But this lets you do things like I/O or something that would not just would not be possible in Sass. And it would theoretically be possible, though I haven't seen it done. Because Ruby is written in C and can have its own C extensions, you could write code in C and then write adapters for different Sass implementations, and you could reuse the code. But that would be a pretty complex thing to do. And so while you can do it this way, I think actually programming in Sass is better. And it's also a very interesting thing to have to do, because as a programming language that isn't designed for programming, you come across all sorts of problems in Sass that you wouldn't come across otherwise and that can be really interesting to solve. Like, I bet none of you have ever had to implement a string replacement function for general purpose web development before. So that's my talk. I hope it was useful. Thank you very much.